So this is the revenue problem that we did, where a small company has revenue in 2008 of $175,000 and it grows to $365,000 annually in 2019. So I asked you to plot that as a on a set of axes, and the vertical axis would be the thousands of dollars, and I chose, since we had to go up to the $365,000 range, I chose to go 100, 200, 300, 400 as my scale on the y-axis. My horizontal axis I chose to be the years since 2000. I thought that would be a good starting point for x equals 0 to be the year 2000. So the first point is 8, 175, and the second point is 19 years after 2000 and $365,000 in revenue. So we can plot a nice little linear function that goes through there, and we want to find a model for that line, so we find the slope of that. And the slope is the rise over the run. So the run is the horizontal and the rise is the vertical. The rise is the change in revenue. The rise is the change in revenue divided by the run, which is the number of years. So how much did the revenue increase in that time? Well, it ended up at 365 and it started at 175. So the difference there is 190 in thousands of dollars. How long did it take for that to happen? Well, it ended in the year 2019 and started in the year 2008, so that's 11 years. And that's about $17,000 per year. There's some decimals there, but I'm not going to worry too much about that because these are just approximations like we've talked about in class. So we'll round to some nice, reasonable number. So basically, the revenue is going up by about $17,000 per year. So how do you find an equation for that? Well, you need to find, like we said in class, a starting point for your information. And you can use either point that you know. So if we use the 175, then my revenue is 175 plus $17,000 per year times x minus 8, which is the years since my start. So my start is in 2008 in that case, with 175 as my value. And that's an equation. I can multiply it out and simplify it if I want to, but this is an equation that kind of shows me where it came from. I know I'm starting at the year 8 with $175,000 in revenue, and I go up by 17 every year. I could just as well have used the other point and had y equals 365 plus the same slope times x minus 19, the other starting point. At the year 19, my initial value, my value is 365. So I can use those as my x1 and y1 for my point slope formula of the equation. And I want to show you on that line how that works. It's really just, I want to find some other point xy on my axis, on my model, and for any point that lies on that line, I know that the rise of a run from the point 8, 175 should be 17, should be my slope. So my run is x minus 8. What if this is x, this is 8, my run is the difference between those. And my rise is going to be the slope times how many years it went. So that's x minus 8, right? So that's 17 times x minus 8. And it started at 175, and it goes up by that much. That's exactly that green equation we have up above, 175 plus 17 times x minus 8. If I had chosen to use the other equation, I would have the same type of triangle, but I would just have this being my run, x minus 19, and my rise would be 17 times x minus 19, starting at a value of 365. So you can use either of those points for your initial point, your kind of anchor point for your model, and just say from that value for the revenue, I move over this many years, and every year I go up $17,000, so I increase by the number of years times 17. So once you have your model, how do you answer questions about that? Well, there's two types of questions you could ask. Either, what is the revenue in a certain year? So I plug in the value for that year. I plug in x equals 40 into either one of my models. That says 21 years at $17,000 a year, and I start at 365. Well, what's 17 times 21? 17 times 21 is 357, plus 365 is 722. And that's thousands of dollars in 2040. So I could plug in my input and get the corresponding output in my model, the predicted revenue for that year. The other direction of this would be, when will I have a certain revenue? Find the input that gives me an output of 500,000. But in this case, my units are thousands of dollars, so I don't want to write 500,000. I want to write just 500, because this represents 365,000, and this represents 17,000. So everything's thousands, so I want to keep them all in the same units. And to solve that, I have to subtract 365 from both sides. So I get 135, which means how long it still has to go up 135,000 from that starting point of 365. And if it does that $17,000 per year, I divide by 17. And what's 135 divided by 17? 135 divided by 17 is about 8. 7.9 equals x minus 19. So that means x equals about 26.9 years after 2000 in the year 2027 or so. So probably we're talking about annual income or annual revenue. So it doesn't make sense to say we hit it on the 0.9 way of through the year, so it's in like December of 2026. Let's just say in 2027 our revenue has exceeded $500,000. Again, you don't need to be exactly precise on this because it's a rough estimate model and an approximation. So if you were really in this business, you would say we project that we will break $500,000 in annual revenue in the year 2027. And you can solve like that. You don't need decimals. So hopefully you can think through these equations, and a lot of you did the process without writing down the equations, which is fine, but I want you to realize that the algebra is doing exactly what your common sense indicated you should do. Adding $17,000 every year until you hit 500,000. This is you can solve it using your algebra skills. Hope that helps.